So we get the same results. So we say that the Euler test is passed. Okay, so when we reach this part, this is the method of solving the exact equation. So when we take m of x comma y and we integrate it with respect to x, and we get the value of f. So on the left hand side we're going to get f, but this f is going to have an unknown function g of y inside of it. So we will need to retrieve or get back the value of g of y for this value of f, or in other words, to complete this function f. How do we do that? We know that n of x comma y, we already have that n of x comma y, which is the second part of the exact equation. It is defined by definition as curly f over curly y, right? So we have found partially the value of f. So whatever the value of f we have found, which in this case is all of this thing, we should be able to put it over here. And when we calculate the partial derivative of this f with respect to y, we should get back some more information, because we will be able to equate this equation with n of x comma y, which we already have, right? So let's put this value of f into this and get like n of x comma y is equal to curly over curly y of integral m of x comma y curly x plus g of y. Now this g of y is a pure function of y. And one more thing, that when we took the integral of this function and we declared that this integration was with respect to x only, we should be able to write dx instead of curly x, right? So just to denote that this integration is with respect to x only, I'm going to just write a small x over here, or just to denote that it's a partial integration. And when you expand this, you get curly over curly y of integral of m of x comma y dx plus curly over curly y of g of y. And of course, needless to say that since this function g of y is a pure function of y, the partial differentiation will actually be just the derivative with respect to y. When you go through all of this, you will find the value of g of y. So let's do another step. N of x comma y equal to curly over curly y of integral m dx. I'm just going to use the short form of m, plus d by dy of g of y. And if I want g of y from this equation, I could write g of y or d by dy of g of y equal to n of x comma y minus curly over curly y of integral of m dx. And if we take integral on both sides with respect to y, we should be able to get the value of g of y. So there are two things. Either you could memorize this final equation to find g of y and this equation to find f. But I would recommend that you don't memorize these equations. Instead, you memorize or remember the procedure we have followed throughout this. And let me revise that procedure. The first step was that we write down a first order differential equation in the form of exact equation as m of x comma y and n of x comma y. Then we verify whether this equation is an exact differential equation or not. So once we do the Euler's test and the equation comes out to be exact, then we go on to the next step. And what do? We use the definition of the exact equation, that the first part, which is written along with dx, is actually a partial derivative of an unknown function f with respect to x, and that unknown function f is the function that we are interested in finding out. Similarly, the definition goes on saying that n of x comma y is actually the partial derivative with respect to y of the same unknown function f, which is somewhere hidden inside m of x comma y. So that means that if we memorize only these definitions and use standard procedures, we should be able to find the value of f of x comma y and getting rid of g of y in the procedure. So let me demonstrate all of this using a problem from the book. So let's do problem number 3, and actually this is exercise 2.4, problem number 3, and which is that you are given with an equation called 5x plus 4y dx plus 4x minus 8y cube dy equal to 0. So first step is actually we don't need to do that because it's already in the exact equation format. So what do we need to do? We need to check whether it's an exact equation or not. So we do the Euler's test. Let me explain the Euler's test a bit, because what did we say? We said that we take the partial derivative with respect to y of m and we try to equate it with partial derivative with respect to x of n. So let's translate m and n with respect to their definitions that we saw earlier, and those definitions were that m was defined as curly f over curly x and n was defined as curly f over curly y. Now see for yourself, if we combine these two products on the left hand side and the right hand side, what do we get? Curly square over curly y curly x of f equals curly square over curly x curly y of f. So the left hand side is equal to the right hand side. So you got an insight about the Euler's test. So let's apply this test to this equation. And this equation, in this equation we're going to write curly over curly y of 5x plus 4y, and we check whether it is equal to curly over curly x of 4x minus 8y cube. Okay, so let's take the derivative of y on the left hand side. So this can be a bit tricky, so I'm going to recommend to you, if you see an x anywhere, because we're differentiating with respect to y, simply change it to a constant k and name it k. So curly over curly y of, and when k multiplied with 5, what will it become? It will become a new constant, right? So let me call that new constant, which is 5 multiplied by k, as a new constant, let's say c, plus 4y. And similarly I'm going to do the same thing over here. When you do a little bit more practice, you should be able to skip this step. So here we are going to take the partial derivative with respect to x, and we're going to consider anything in y as a constant, right? So let me write it over here, 4x minus 8k, right? And if we are taking 8k, I can simply call it an arbitrary constant c. And if you are getting a bit confused, let me call this k1, and let me call this k2, let me call this c1, and let me call this c2, right? So what is the derivative of a constant? Actually, let me expand this. Curly over curly y of a constant plus curly over curly y of 4y equal to curly over curly x of 4x minus curly over curly x of c2, right? So the derivative of c1 is, or any constant for that matter, is 0, right? And here also the constant derivative is 0. So what do we get as a result? The derivative of 4y with respect to y will be how much? 4. And derivative of 4x with respect to x will be how much? 4. So we say that, okay, we find out that the check is true and both the left hand side and right hand side are equal. So the Euler's test is passed, so that we can state that the given equation, the given differential equation is actually exact, right? So now what do we need to do? We need to solve the equation, right? In order to solve the equation, now we need to remember at all times that 5x plus 4y is m and 4x minus 8y cube is n, right? Now I'm just using my memory that we defined m as curly f over curly x, right? This was m. And what is the value of m given to us? 5x plus 4y. So 5x plus 4y. Now what am I going to do? I'm going to write curly f equal to 5x plus 4y into curly x, and then I'm going to take the integral on both sides. So on the left hand side I get f, and on the right hand side, before I do anything, I must write here, because it's a partial integration, so I need to include a constant of integration, which is g of y, because we're ignoring a variable y. So in all of this equation, we are going to consider anything which is in y as a constant. So right now I'm going to skip the assuming y as a constant and writing a k instead of it, because we have done similar things a couple of times. So I'm going to take the integral. The integral of 5x would be 5x square over 2, right? And since 4y completely as as a product is a constant in this context, we take it out of the integral and we get integral curly x over here, right? Everything in y will be considered a constant and can be taken out of the integration. Similarly, here we get g of y, and then we write down f equal to 5 over 2x square plus 4y. And what is the integral of 1 with respect to x? Simply x, right? So this is g of y. I hope you got up to this point. Now, this solution could be valid if we didn't have g of y over here. So we need to find out the value of g of y. How do we do that? We use the value of n of x comma y, which was given to us as 4x minus 8y cube. So we write down n equal to 4x minus 8y cube was defined as curly f over curly y, right? So I hope you understand what I'm doing here is I'm not remembering any equations. I'm simply using logic to and some basic information like the definitions of m and n to solve this equation. So what do we do? On the left hand side we have already substituted the value of n. On the right hand side we're going to substitute the value of f, which is obtained as this, right? So we're going to use this value of f over here. So we write down 4x minus 8y cube equal to curly over curly y of 5 over 2x square plus 4yx plus g of y. So what do we get? 4x minus 8y cube equal to, now we have to take the partial derivative of each of these terms with respect to y, and we will be using the same procedure that we saw earlier. So since x in this context is a constant, multiplied by or divided by any constant, it remains a constant. So all of this thing is a constant with respect to y. So what do? We say that if we differentiate a constant, there is not going to be a change in that constant, so the change will be 0. So the derivative of this thing with respect to y or any other variable, since all of this is right now assumed to be constant, is 0. The derivative of this constant is 0. Similarly, in this context, x is constant and 4 is also already a constant. So 4x can be taken out of the derivative and we should be able to write 4x, and then we take the derivative of y with respect to y, which is 1. So you stop here and the answer is 4x for the second term. For the third term, we saw earlier that this is the derivative of g of y with respect to y, because there is only going to be one variable y. Here we can see that 4x is being cancelled with this 4x, and we take integral on both sides. Integral of g prime of y equals, and instead of g prime of y, let me write down d by dy of g of y. So this is the equation. For integration, let me prepare this. So I can write the derivative of g of y equal to minus 8y cube and dy. Now we take integral on both sides, and on the left hand side the integral and derivative operators cancel each other and we get g of y. And by the way, at this step you have to include a constant of integration. So if you have forgotten the concept of constant of integration, please see my upcoming video. I'll be posting a video for constant of integration as well. So we get for the second term we get minus 8y cube y4 divided by 4. This is the integral of y power 3. Okay, so we get a constant of integration here. So this is g of y. So now we substitute the value of g of y in the final value of f of x comma y that we got earlier. Let me copy that value over here. F is equal to 5 over 2x square plus 4xy plus g of y. So now we get minus 8y4. Actually 4 and 8 are going to be divided like this. So we get minus 2y4 plus c, and we get f as 5 over 2x square plus 4xy minus 2y4 plus c, right? So this is the final value of f, and one step is left, that we have to equate this f of x comma y with 0 to reflect the solution in terms of x and y. So we do that. 5 over 2 x square plus 4xy minus 2y power 4 plus c equal to 0. So this is our final solution. I hope you understood this concept and how we solved. So if you have any questions, please leave the questions in the comments, and I hope you liked this video. Subscribe to keep in touch, and see you in the next video, inshallah.